In this video, we're going to be taking a look at the Creality Sonic Pad, and I'm going to get you guys started with a basic unboxing, the setup, the slicer changes that you need to make to work with the Sonic Pad. I'm going to be using Prusa Slicer for that, and that's something that I've seen a lot of other people in YouTube videos just completely gloss over. So I'm hoping to clarify a few things there for you guys. I've also got a custom mount for the Sonic Pad. Right now you'll see it's on this Ender 5 S1, but it can mount to any printer that's just using 20 series extrusion, and it requires no additional hardware. I've also got a mount on the hot end for the accelerometer that comes with the Sonic Pad to measure those resonant frequencies for input shaping. All of those design files I make available to you guys for free. And at the end of the video, of course, I'm going to give you guys my opinion on the Sonic Pad. I'm going to be demonstrating this on the Ender 5 S1, but this whole process is very generic to any Creality printer that the Sonic Pad supports. Now, the Ender 5 S1 is a printer that was sent to me by Pergear, and it turns out they're the ones who also sent me the Sonic Pad, so a big shout out and a big thank you goes out to Pergear. Please check them out in the video description down below. I'll put a link down there to their website. So let's go find out if we're about to go super sonic or if this thing sounds too good to be true. For those of you who do not yet own a Sonic Pad, let's take a quick look at what's in the box. So, under the lid, you've got a sheet of stickers, and then you have the Sonic Pad itself. It's nicely wrapped in this protective cover, and that's good because I've heard that the screen is pretty easy to scratch. And at the back of the Sonic Pad, you can see a few different connections. You got the DC connection, USB ports, a LAN connection, and a port for a sensor, which is, I'm going to assume, for the accelerometer. At the bottom of the box, you have your quick start manual, and this should be enough to get us going. And finally, in this box here, we should have most of our accessories, things like USB cables, USB adapters, the accelerometer sensor itself, which is pictured right there, the DC power adapter, a USB stick, and the different outlet adapters for various regions around the world. The setup should be quick and easy, and I hope so because this is a big part of what you paid for. And so after powering the unit on, you're going to go through these series of prompts like selecting your region, your language, agreeing to some terms and conditions, entering in your password for your Wi-Fi, and then giving your Sonic Pad a cool and unique name. Then we can select what printer we're working with from the list of preloaded printers. And in this case, I'm going to be using the Ender 5 S1. So I'm going to head over to the 5 series and not see the Ender 5 S1. I'm assuming this is because I have an older version of the firmware. And so I power cycled the Sonic Pad, and then the second time turning it on, now that it's been connected to Wi-Fi, I was presented with the option of upgrading the firmware. And then after the firmware update, the system restarts itself, and we're going to go through this process one more time. Although the second time around it was much quicker, the Sonic Pad remembered everything except for the custom printer name. Now in the Ender 5 series, you'll see that the S1 shows up, and there's two versions. Mine is the one with the limit switch, as I have one of the earlier versions. So I'm going to select that, hit next, and now it's going to tell me to insert an SD card or some sort of USB memory stick. The Ender 5 S1 uses a full-size SD card, and so I'm going to be using a micro SD inside of a USB adapter. I'm going to be flashing the firmware to this micro SD card, and then I'm going to be inserting the micro SD into a full-size SD card adapter. And for flashing firmware, a lot of these printers don't like SD cards larger than 8 gigs, so I would find something that's 8 gigabytes, and this should work reliably for you. Put the SD card in the printer and turn it on, and you may notice that the screen on your printer may no longer work. Don't panic, this is normal. Then just continue to follow the on-screen Sonic Pad prompts, because the next thing to do is to connect the printer via USB to the Sonic Pad. It will tell you to use a specific USB port, so unlike me, pay attention to that prompt, and if you're not sure which USB port to use, click the button that says View USB Schematic, and it will show you which one it's asking you to use. The printer and Sonic Pad will then coordinate a series of self-tests, such as turning fans on and off. Again, just follow the on-screen prompts and ensure everything is working correctly. The next part is the bed leveling. Now, if you've already been using your printer, there's a good chance your print bed is already leveled, so do not follow the on-screen instructions and do not twist your bed leveling knobs all the way down. Just don't touch it, leave it alone. You can just press next and the printer will home itself in both the X, Y, and Z, and then we're going to get into setting up the Z offset. This is done with the tried, tested, and true method of a piece of paper between the nozzle and the print bed. And on the Sonic Pad, you can see a series of measurements by which you can incrementally adjust the position of the print bed with respect to the nozzle. And just for fun, on the Ender 5 S1, down is up and up is down. And I'm just going to go ahead and assume the logic behind this is that the frame of reference is the nozzle and not the print bed. And if you've never done this before, you want to jog that print bed up to a position where that piece of paper is getting squeezed between the nozzle and the print bed. There should be a light to medium amount of drag on that piece of paper. You don't want to be punching a hole in it. The Sonic Pad will then home the printer again, and we're off to the auto bed leveling. And just as I've recommended in many videos before, you want to let the print bed heat soak for a while before doing the auto bed leveling. So I'm going to set it to 60 degrees, I'm going to come back about 5 minutes later, and then I can start that auto bed leveling procedure. 25 points on the print bed will be probed with the onboard CR Touch, and I've noticed that this process is quite a bit faster than it had gone before with the stock Ender 5 S1 firmware. And this is good because, of course, nobody likes waiting around for all 25 points to finish if they're going so painfully slow. Once the probing is done, take a look at the visual representation of the bed mesh and make sure that everything looks okay and it's not too wonky. If the mesh is looking super warped, you may want to verify that in fact your print bed is damaged or warped, or you may want to try and probe again. Now before we jump into the input shaping calibration, I'm going to do a quick weight reduction modification to the print head, and that's just by removing the metal front cover, which weighs almost 50 grams. That will provide a theoretical improvement in performance once this print head starts flying around. To get the input shaping set up, we have to attach this accelerometer somewhere on the print head, and there really isn't a good place to mount it. Now I've seen some people use double-sided tape and some other less than optimal solutions. Now since we've taken the original cover off, I've taken it upon myself to design a cover that integrates a mount for the accelerometer. To get the new fan grill and mount installed, you'll simply just remove the two M3 screws holding the fan to the hot end. Grab the new fan grill, and on the top you can see the two holes that we're going to be using to mount the accelerometer. And we're going to be first mounting this grill on top of the existing fan, and for that you're going to need two M3 by 25 socket head cap screws. And don't forget, if you're looking for the STL for this fan grill, you'll find it in the video description down below. And also don't forget to keep watching to the end of the video because I have another upgrade for you guys later on that you can download on my printables page. And now we can take our accelerometer and we can mount it with some M3 by 8 socket head cap screws, or you can use any other thread forming screw if you have some of those to just thread directly into the plastic. Just make sure that when you install the accelerometer, it's in this orientation so that the markings on the top of the accelerometer X, Y, and Z are all facing in the correct directions. The other end of the sensor gets plugged into this port at the back of the Sonic Pad labeled sensor. The connector is keyed so you can't screw up which way you put it in the Sonic Pad. Then in the menu, head over to Other Settings, scroll down a little bit, and you'll see something that should say Advanced Options. And within Advanced Options, you'll find something that says Measuring Resonances. And then you can select what style of printer you have, and in our case, we're using an Ender 5, so I'll select the Ender 5 style printer. We've already attached the sensor to the printhead, so I can just press Next. And now we're ready to go. The Sonic Pad will then vibrate the printhead in both the X and Y directions, trying to find some bad resonant frequencies. And this is super cool because now during a print, the Sonic Pad will try and employ some software tricks to drive the motors to avoid those resonant frequencies and result in less imperfections on your print. This is the part where we talk about the slicer settings, and this is something that I found a lot of other YouTubers have skipped altogether when reviewing the Sonic Pad, especially if you're a person who still wants to use Prusa Slicer. In Prusa Slicer, I already had an Ender 5 S1 profile, and you'll see here that I just saved a new copy and I called it Sonic Pad. Up at the top, you can still see that I'm using version 2.5.2, in which case I'm going to be using the G-code flavor Marlin Legacy. They have released at this time 2.6, which will have a Clipper G-code flavor. Over in the machine limit section, you're going to change that top field to Use for Time Estimates. Make sure it does not say Emit to G-code. This is going to ensure that your machine will use the acceleration values on the Sonic Pad and not the ones in these fields in your slicer. And if you want your slicer time estimates to be accurate, be sure that you change those settings in the slicer to match the ones on the Sonic Pad. Everything else remains the same, and those are the bare minimum changes to get you up and running. If you want to send your slice G-code files directly from Prusa Slicer to the Sonic Pad, this is very easy to do. You need to set up a physical printer. Click the gear icon beside the printer name, then head over to your Sonic Pad, check out your network settings, and in your wireless network, you'll find the IP address posted up right on the screen. You're going to take that IP address and you're going to put that right in the host name, IP, or URL, and you're going to have the host type set to Octoprint. Clicking the test button will let you know if you have a successful wireless connection, and the API field can be left blank. Now, I made sure that profile is saved, and you'll notice on the right hand side the printer still says Physical Ender 5S1. And when you do this and you reslice your file, in the bottom right hand corner you'll see a different symbol than what you may have seen before setting up a physical printer, and that is that letter G. And if you click on that, you'll now have some options to send the sliced file directly to your printer, and you can also set it up where you can just do a one-click upload and print, and it'll immediately start the print. In this case, we're just going to upload it. One important thing to consider is that if you don't have your Sonic Pad set up for a static IP on your network, every time you power cycle the Sonic Pad, it may end up with a new IP address, and you'll have to change that in Prusa Slicer. And if you're not printing directly from your slicer, you can always start the print from the Sonic Pad screen. On the main screen, just press the print button in the bottom right hand corner and it'll bring up the file list. When you find the file you want to print, hit the little icon that for some reason looks like a paper printer, and the print will start. If you have a print preview embedded in your G-code, it'll show up there, and if you hit the adjust button, you can make live adjustments to things like the Z offset, flow rate, turn fans on and off, and all of that fun stuff. Alternatively, you can access the web dashboard by opening your browser and typing in the IP address of the Sonic Pad in the address bar. Now, I filmed this screen capture after having owned the Sonic Pad for quite a while, so you'll see down in the file list I already have lots of files uploaded, and there's currently a print already running. But to start a print from this screen, it's very easy. Just head down into the file list, right click on the file you want, and then hit print. To get the files on the Sonic Pad, you can just plug a USB stick into the side of the Sonic Pad, or like me, you can transfer them directly from the slicer, like I already showed you guys how to do. And the third option is using Creality Cloud. And not really related to starting prints, but relevant to the web dashboard, on the left-hand side, you'll see an additional menu. In these menus, you can access more advanced features like the configuration files, the system settings, as well as a terminal window, and much more. Also in the settings, you'll find that you can personalize your dashboard. You can use light or dark themes and change the accent colors. You'll see here that I have a pinkish purple, and yours from the factory might still default to blue. Now we can take a look at the first Sonic Pad print, and I chose this vase mode diffuser lens that I'm going to use for an LED smart bulb. Now, I specifically chose this model because I figured that in vase mode, the continuous nature of movement would create a very impressive motion, and I figured with all of the ripples along the surface that it would induce a lot of vibrations if the print head was moving very quickly, and we'd be able to test to see if that input shaper is working. And this print did come out looking very nice, but what good is that if we don't have any sort of baseline reference to compare it to? Since I knew I was going to be making this video, I took some time before upgrading to the Sonic Pad to use the Teaching Tech 3D printing calibration webpage to do my best to optimize the Ender 5S1 out of the box. On his page, he does have tools to set up things like input shaping and pressure advance, but I did not use those ones. I limited myself to using only the tools by which I could change settings within the stock firmware. By default, Creality uses Marlin firmware in their printers out of the box. But unfortunately, even with a lot of their newer printers, things like input shaping and pressure advance have not been activated from the factory. In order to get access to those more advanced settings, you'd have to cook up your own firmware build. And in my opinion, that would sort of defeat the whole purpose of this comparison. And so I spent a lot of time doing flow tests, as well as ringing towers and calibration cubes, in search of the highest accelerations, the highest flows, and the sharpest corners. And after all that time, I was ultimately a little disappointed in the results. I think I was hoping to find some magical combination of settings that was a one-size-fits-all solution for all of my 3D printing needs. And I think that not all, but at least some people use these tools with that same intent and perhaps misunderstanding. I found that these tools were best used for finding the upper limitations of your printer's basic settings such as flow, speed, and acceleration. And then with some level of troubleshooting and 3D printing experience, you could identify the hardware that is causing those limitations, such as a poorly constructed frame or perhaps an undersized part cooling fan. Fixing those issues may increase your machine's upper limits, but it may not result in higher quality prints at higher speeds for every single model that you print. This goes back to there not being a one-size-fits-all solution for all of your printer settings. In my opinion, the different geometries of the different parts that you're trying to print will require you as the user to make intelligent decisions when setting up your profiles. Now, if you have the ability to configure your own firmware with the more advanced options like pressure advance and input shaping, this will provide you with some amount of forgiveness if you're a little overzealous with your acceleration and speed settings. Configuring your own firmware isn't an impossible task, lots of people do it. However, it can be a little frustrating for the very first time, and you can make some potentially expensive mistakes, damaging some of your equipment. And this is where the Sonic Pad comes into play. As you saw earlier in the video, it's pretty easy to set up, and that's why you ponied up the extra money for it. And now you have access to those more advanced features, which will compensate for the aggressive print settings that would have otherwise caused issues before upgrading to the Sonic Pad. And the reason I bring all of this up is that my initial prediction for the Sonic Pad was that it was going to increase the print speed, but I really didn't have a whole lot of faith in those advanced features, and I thought that there was only so much that they could do to maintain print quality while increasing speed. And spoiler alert, it turns out that I was wrong. And I'm actually quite happy that I'm wrong, because now we have a tool for beginners to use that will allow them to achieve those higher print speeds with less headaches. Ultimately, I still think you'll have to make some intelligent decisions when setting up your slicer settings or your machine limits to achieve a particular outcome in your prints. But we are one step closer to easier, smarter 3D printing. So let's take a look at those results. For the before and after tests, I selected 3 different models. Each model has its own unique shape and geometrical features that I thought could bring out either the best or potentially the worst in both Marlin and Clipper setups. I first printed all of the parts with the original Marlin firmware, and I modified all of the acceleration, jerk, and print speed settings to the point where the print quality was still good enough that I would feel comfortable selling these parts to somebody. In my opinion, there's no value in producing parts at a faster speed if the part quality is so bad that they're basically just considered garbage anyways. And so just as I had discussed in the previous section of this video, I had to very carefully tailor the print settings for each of the models to maximize the speed while maintaining the quality. Now in contrast, once I switched over to the Clipper firmware, I did not have to be as careful with my print settings. I only had input shaping configured, and I used all of the default values for the Ender 5 S1 within the Sonic Pad to produce these parts. This was essentially my attempt at demonstrating how effective input shaping is at compensating for those resonant frequencies and producing high quality parts at a very high speed. On average, I saw a reduction in print times by about 20%. I could have slightly increased the print speeds, but I would likely not have seen a significant reduction in print times due to the size of the parts. Also, I wanted to use the default Sonic Pad settings for the Ender 5 S1 to show the out-of-the-box performance with 0 tuning. The first set of parts we'll be looking at is this nut and bolt combination. They feature these nice curved surfaces with abrupt changes in direction, and of course the very distinctive male and female threads. On the left-hand side we have the original firmware, and on the right-hand side we have the Sonic Pad version. Upon closer inspection, the parts with the original firmware still look very good. The threads still fit together, and the curved surfaces still look quite smooth. In some areas on this outer conical face, where the print head obviously changes directions from that edge, you see some signs of ghosting or ringing, but this is sort of to be expected with the acceleration values that I was using. Truthfully, to see it, you do have to look pretty close under a nice bright light, so by no means is this a bad part. For this print, I had set the slicer to slow down the print speed if the layer time was going to be less than 7 seconds. This would ensure the part cooling could keep up and the threads would come out crisp and the part would still be functional. I had put the same limitation on the print speed on the Sonic Pad version, as I obviously didn't change any hardware for these tests. Therefore, the male threaded portion of this part could have actually been completed a lot faster in both the Marlin and Clipper versions, but in this case it came down to hardware limitations instead of software limitations. Again, this goes back to what I was saying earlier about the user having to make intelligent slicing decisions based on the part geometry. A Sonic Pad with fancy party tricks like input shaping will only compensate for things like machine vibrations. At the end of the day, if you want nice looking prints, you have to understand the limitations of your machine and how to compensate for them yourself. So that being said, the Clipper or Sonic Pad version of these parts did finish 20% faster, and from my estimates, all of that time savings was in the conical areas of the part. The minimum layer time setting would have slowed down the Sonic Pad print in the male threaded portion of the print. So this seems to check out, since the threads look about the same in quality, as the two versions would have both been slowed down to about 7 seconds per layer in the male threaded portion. But remarkably, in the curved cone area, there's noticeably less ringing, and the surface quality is extremely high despite the 20% faster print time. I honestly wasn't expecting this significant of a difference, and frankly, I was very impressed. It actually even looks better in person than it does on camera. Unlike the time and effort I tried to put into tuning the Marlin version, I literally put 0 time into tuning the Sonic Pad, and as I mentioned, the acceleration values are the default Sonic Pad settings for the Ender 5 S1, and I left all of the print speed settings the same between the Marlin and Clipper versions of these prints. I'm confident that with a little bit more testing and tuning, I could save even more time and end up with the exact same part quality, so there's still some performance gains to be had if you want to invest that time. Next, I have the two halves of the shells of my snap latch cases. And again, on the left is the Marlin version, on the right is the Sonic Pad version. Right away, you'll notice some very fine stringing and wisping on these parts, and this is something that this machine, the Ender 5 S1, has always done for me right from the start. No matter the retraction or material temperature settings, it's something that I just can't seem to get rid of on this machine, but at least it's very easy to clean up. The other thing that may have caught your eye right away is the difference in how those first layers look. On the Sonic Pad version on the right, I was still trying to dial in my first layer Z offset, and that first layer needs to be squished just a little more. On the Sonic Pad, I do wish that they had smaller increments of Z offset adjustment, as the smallest increment is 0.05 millimeters, and I would have liked to have adjusted it by less than that. These cases were printed at 0.3 millimeter layer height, and you can see in the 45-degree overhangs of those chamfered edges, there was a little bit of struggling with what I think is the part cooling in this area. I don't think those overhangs turned out particularly nice, both on the Marlin or Sonic Pad versions of this print. They're both still very acceptable parts, and I just want to bring this up again because I want to really drive home the idea that not one particular upgrade like a Sonic Pad is a magic bullet for perfect parts. What is noticeably better though is those surfaces on the Sonic Pad version, especially between and around the edges of those reinforcement ribs on those cases. The input shaping is proving to be very effective at getting rid of the ghosting and ringing, and you end up with extremely smooth surfaces. And since the bottom halves of these cases are more or less mirror images of the top, not surprisingly, you get more or less the same results on the bottom half. The reason I selected these parts for the comparison was that they have a lot of straight and flat surfaces with some 90-degree changes in direction. I wanted to see if the higher acceleration values used on the Sonic Pad would result in different time savings for parts with different geometries. And for these parts, it turns out that the time savings was still about 20%, which was the same as those first parts with the threads. And just to be clear, for these parts, I also did not modify the print speed settings, so those speeds are the same between the two parts, and the only difference is the firmware in which the default accelerations for the printer have changed. Finally, we have these vase mode diffuser lenses printed in a matte white PLA. And again, the Marlin version is on the left and the Clipper version is on the right. The purpose of using these prints here was to have a vase mode example where there would be no complete stoppage of the print head, and instead there would be a lot of changes in direction with the ripples on the surfaces of these parts that would still induce a lot of vibrations into the machine. It was very hard to capture on camera, but on the Marlin version on the left, you do see a lot of inconsistencies in the surface, whereas on the Clipper version that I'm holding here now, the surfaces turned out noticeably smoother. To me, this just further validates the input shaping feature on the Sonic Pad, so much so that you see an increase in part quality with a decrease in part printing time. In an attempt to better capture the surface quality on these parts, I took my cell phone flashlight and put it behind these lenses. This first one being printed on the original firmware, I think this makes it a little more obvious what I'm referring to when I say the inconsistencies in the surface. It's almost textured in a way. Whereas on the Sonic Pad part, it's considerably less noticeable. And since this is the actual application for these diffuser lenses where a light will be sitting behind them, clearly I prefer the version with a lot less imperfections. If you guys are looking for an open source 3D printed smart light project where these lenses are being used, check the video description down below. And as I've done with many of my previous videos, I always try and provide you guys with some extra value as a means of thanking you for tuning into my content. For this video, I'm providing you guys with some free printable files for a Sonic Pad mount that I designed. If you guys appreciate this sort of thing, please consider subscribing to my channel or supporting me in any way that you can. I'll put a link to the design files in the video description down below. You're going to need to print all of the files except for the tie bars, of which you'll print 3 of them. Now I printed all of mine in different colors, so it's easy for you to discern what's what. Also, the parts that are labeled mounts, which I'm holding here in purple, are labeled with a left and right hand side. Similarly, the parts labeled bases, which are orange, also have a left and right hand side marking on them. And we can start by assembling these purple mounts with a single tie bar. The left hand side mount goes in your left hand, as you can see I'm holding here, and a tie bar will snap into place. And the right hand side mount will go in your right hand and the tie bar will snap into place, and the holes in the tie bar should be facing the letters. We're going to do something very similar here with these bases. So the left hand base will go in your left hand, the right hand base will go in your right hand. You'll take another tie bar and you'll be snapping those into place as well. And in this case, on the bases, it doesn't matter which direction those holes are facing. If your printer tolerances are decent, it's going to be a medium press fit. Friction will hold these things together, so squeeze pretty hard. Now we have to remove the original arms from the Sonic Pad, and to do that, you'll find these small hex head shoulder screws on the sides of the arms. Don't discard these because we're going to be reusing them for our new mounts. Remove the one on the other side and also put it aside for safekeeping. Now you can grab the mount assembly, and we're going to be attaching it to the bottom of the Sonic Pad, and the bottom is the side farthest away from those ports. You'll notice some small hooked features on these mounts, and those go to the front side of the Sonic Pad, and the left and right labels are on the back side, and those will snap over tops of the sides where the original arms used to go. The holes on the mounts will line up with 2 of the threaded holes in the Sonic Pad, and you can reuse the original hardware and secure these pieces down. I made those counterbore holes a very tight fit around the bolts so nothing wobbles around. You may have to push pretty hard. And do not over tighten those bolts because the side faces of the Sonic Pad are drafted for the injection molding process, and so we don't want those purple pieces skewed. Just lightly tighten them and let the tie bars keep those 2 pieces parallel to one another. Now obviously we want to mount this thing to our printer, but if you ever do want to still run the screen as a standalone screen, you can just flip it upside down and it'll tilt it at a nice angle for you to still press all of the buttons. And in the software, you can actually just flip the screen in the advanced settings, so it'll still work just fine. Another cool feature are the notches in the tie bar, and you can use those to press the cables in them, or you can also use zip ties to secure your ties around those notches for better cable management. And now we can attach the mount to the base, and to do that, you can hook in the first 2 teeth, and then you'll notice the rest of the teeth will almost align. And if you just take your thumb and forefinger and squeeze in those 2 places, the rest of the teeth will snap into place. One side of the teeth are open and the other side are closed. And so if you ever want to remove this, rather than unsnapping the piece, you can just simply slide them apart by pushing on the side. As you move the screen into lower, more tilted positions, less teeth will be engaged and the snap fit will require less force. Getting this mounted to the bottom of the Ender 5S1 is very easy. The first thing we need to do is just remove the channel cover on the bottom extrusion. Then we can plug in our DC power jack and our USB cable. We can attach our base, snap it down into place, and then on the base, you'll notice that there are these hooked features. Tilt them down into the channel and let the whole assembly fall into place, and gravity will take care of the rest. In the upright position, the unit doesn't stick out too far from the frame, and in the tilted position, it doesn't go inside of the frame far enough to hit the print bed in its lowest position, so everything fits quite nicely. Now personally, I prefer the unit down there in front of the old unused screen, but we do have an extrusion up at the top, and the top channel is exposed, so there's nothing stopping us from moving that entire unit to the top. And since this mount hooks into any 20 series extrusion, technically this whole thing is compatible with any printer that uses aluminum extrusion. And if you guys are feeling extra generous and want to support me and my work and these videos, head on over to my website, embracemaking.com. You can find these parts in the 3D printing section under Universal Accessories. What's best is that supporting my work in this way gets you something tangible in return. So when I first started looking into the Creality Sonic Pad, I thought there was some potential for a performance improvement, but I wasn't entirely sure if it was worth the price or the hassle. Now, it's not often that something actually exceeds my expectations, and maybe it did in this case because my initial expectations were so low. At the very least, it does seem to do what it promises to do on the website, which is a great start, and that's more than what can be said for most consumer grade 3D printing equipment these days. As you guys saw in the video, it was super easy to get started, and the only little bits of information that I had to go search out on the internet was the slicer setting parts, which now that I've put it in this video, hopefully that answers some questions for you guys, and that'll make your life a little bit easier. But I think it was the performance aspect of the Sonic Pad that I was most impressed with, and a lot of that had to come down to the input shaping feature, which you guys saw was also very easy to set up. Just mount the sensor, press go on the Sonic Pad, and the Sonic Pad takes care of the rest. Now, of course, you could set up input shaping on Marlin. I mentioned that earlier in the video, but that would require you to kind of do it like the hard way, where you have to configure your own firmware for whatever printer that you're using. Obviously, before doing this video, I did a whole bunch of research into the Sonic Pad, and I came across some pretty common complaints with this thing. One of them was that the screen scratches very easily. Now, I haven't had that happen to mine yet. Because I read those comments, I've been very careful not to drag it across any rough surfaces or use my fingernails on the screen. So luckily, like I said, I don't have scratches yet, but just a warning for you guys, be careful. The other thing that I came across that I saw a lot of was, and I think this was earlier in the sort of initial release days of the Sonic Pad, was that people were having issues getting it set up with even Creality printers. Now again, a lot of those date back to when this thing was initially released. There's been a whole bunch of firmware updates since, which seem to have taken care of all those issues. So I can't personally say that I've had problems with it. It's been super easy for me to get started with and very easy for me to continue working with. So again, hopefully all of those issues have been taken care of. The other common thing that I saw people complaining about online is the value of the hardware. And they're saying that for what you pay, you're not really getting that great of hardware. And I can find an old tablet in my drawer that's more powerful than the Sonic Pad, and I can flash Clipper on it, and it's gonna be way better. And maybe that's true, that you can find an old tablet or something else to run Clipper on, that's gonna be more powerful than the Sonic Pad, but the Sonic Pad seems to do, again, what it's supposed to be doing. So I'm not sure that the hardware is limiting it, at least for the basic or intermediate operations that it needs to do. And you have to also remember that you're paying for the convenience. A lot of what you're paying for is the fact that, it takes 5 minutes to set up. You don't have to know anything about Clipper. You don't have to know anything about flashing firmware. You follow the instructions on the screen, you select a pre-configured profile, and you're up and running in like 5 minutes. And I think that is the type of person that Creality is marketing the Sonic Pad to, somebody who just wants to get up and running and they want their printer to go faster, and they don't want to really get into the weeds of Clipper and firmware. And if you are the person who does want to deep dive into all of that stuff, that's great. You have so many options out there, there's so much documentation on it, and feel free to go the DIY route. And traditionally, I've been the person who wants to do everything myself, and I'm not denying there's no benefit to that. Clearly, you'll have a much more thorough understanding of the firmware and the printer and how those two things are interacting with one another. But in this case, day to day, most of what I'm going to be doing with the Sonic Pad is from even just a beginner or intermediate standpoint. And so it's truthfully not really worth the hassle to me to go through that. And if you're the person who's running a small business, a print farm, you probably don't want to have the downtime, or you may not want to invest the personal time into figuring all of that stuff out. This thing, you can just plug it in and get going in 5 minutes, and it'll pay for itself probably within the first day. And while we're on the topic of value, this thing can apparently run 4 printers simultaneously. So for one Sonic Pad, you can speed up 4 printers. And that's not something that I've tried yet personally. I've seen it on the Creality YouTube page, but it is something that I want to try in a future video and verify that there is no reduction in performance while you're running 4 printers at once. Also in that future video, I want to cover more advanced features like pressure advance and being able to write macros so that you can slice one G-code file and dynamically switch between materials without having to reslice that G-code file. So stay tuned for those. And so overall, I've had a very positive experience with the Creality Sonic Pad so far. The only minor issue that I've had with it and continue to have with it is the Wi-Fi. So it connects to Wi-Fi perfectly fine. It shows that it's connected. However, if I try and access the web interface, or if I try and send files directly from my slicer, it doesn't always work. I end up having to go back onto the actual Sonic Pad itself, disconnect from my Wi-Fi and reconnect, and then everything seems to work again. This does happen every once in a while, so I'm not sure if that's something that Creality needs to address in the firmware, or if that's a hardware problem, or it could just be my Wi-Fi in my house. Not entirely sure, but thought I'd mention it. And finally, I just want to send another big thank you out to PerGear, who sponsored this video by sending me the Creality Sonic Pad, and who originally also sent me the Ender 5 S1. And if you want to see my video about the Ender 5 S1, click the link in the top right-hand corner of the screen right now, and I'd highly recommend that you guys go check out my sponsor. Down in the video description below, I'll put a link to their website. Also, don't forget, in the video description down below, that's where you're going to find all of the relevant links to the various things that I've mentioned in this video, so please be sure to check that out. And if you guys are looking to support me, check out my website, embracemaking.com. You'll find all sorts of cool and fun 3D printer upgrades and accessories. Thanks for watching.